Afternoon. Welcome to the 5G Hub Summer Speaker Series on 5G and Edge Computing. We are so excited to have you here at the 5G Hub. This is where we create new solutions that leverage the capabilities of 5G. And we want to partner with you. We want to build this ecosystem that will enable 5G to reach its full potential and truly transform our world. And today, we are going to do exactly that through insightful conversations, knowledge sharing, and discussions all about 5G and edge computing. So let's welcome our panelists out on stage. Come out, you guys. Jim, John, and Mehul. All right, welcome. Thanks, you guys, for joining. You guys are in for a treat. We have some amazing panelists with us today. And first, I'd like to introduce Jim Brisimitzis. Jim is the founder and general partner of the 5G Open Innovation Lab here in Seattle. 5G Oil is a community partnership of private and public sponsors focused on discovering, accelerating, and promoting future connectivity, edge computing, and artificial intelligence-inspired technologies. Jim also has over 19 years of enterprise, channel, and startup experience through companies such as Bell Canada, Nortel Networks, PeopleSoft, Oracle, and over 13 years with Microsoft. I met Jim about 3 years ago when you were starting 5G Oil, and I gotta say, not only do you bring a wealth of knowledge and expertise, you have to be one of the most committed and passionate people about 5G innovation.
I sure am, yeah.
Yeah, especially positioning Seattle and Bellevue as a global leader. So thanks for being here today, Jim.
Appreciate it, thank you. And congratulations on getting my last name pronounced right, by the way.
Thank you. Awesome, I did it. I'd like to also introduce John McCready. John leads the product management organization for Dell's initiatives in telco edge computing, private wireless solutions, and the 5G radio access network. Prior to joining Dell last year, John was Chief Strategy Officer at Ribbon Communications, a company focused on optical transport products as well as VoIP infrastructure, SaaS solutions for enterprise and carrier customers. He has spent most of his 30-year career working in product management, strategy around communication industry. I had the privilege of meeting John today for the first time. He flew all the way out from Boston, so thank you for being here, John, and excited to hear about what you have to say about 5G and edge computing.
Looking forward to it.
Awesome. And then we've got Mehul. Mehul represents T-Mobile here today. Mehul is a distinguished member of technical staff and senior director with T-Mobile in the core network services team. Over the course of his 17-plus years at T-Mobile, Mehul has been integral to several initiatives, from the launch of unlicensed mobile access, 3G data services, to spearheading architecture and the design of Google Fi, several T-Mobile MVNO partnerships, and connected car launches with Volkswagen and BMW. He currently is responsible for strategic technical work streams such as private networks, edge computing, and played a leading role in the launch of T-Mobile's advanced network solutions. Mehul has also been instrumental in leading the design here for our architecture at 5G Hub, and like us, is committed to bringing new 5G innovations to life. Thank you, Mehul. All right, so again, our topic for today is 5G and edge computing. So 5G is the latest evolution of wireless networks, providing faster speeds, support for more devices, lower latency, and increased reliability. While edge computing delivers compute, storage, and networking closer to the applications, devices, and end users. Together, they can empower new applications and solutions across a variety of verticals. The goal for today's discussion is to share and learn about these capabilities, the benefits, the challenges, and opportunities with 5G and edge computing. All right, so let's get started. Here's the plan. I'm going to spend about 20 minutes asking our panelists some questions, and then we're going to turn it over to the audience. So you guys get your questions ready. Okay, so we were talking earlier, actually, before the session, and we thought the best question to start with is a simple one. Well, actually, it's not simple. What is edge computing? Because there's still a lot of confusion of what is edge computing, especially as it relates to cloud computing, hybrid solutions, MEC. You guys want to maybe take a stab at this and help us understand what is edge computing?
I'm full of opinions on it, but John from Dell, I think you probably got a good perspective.
I'm happy to go first. Sure. So I think one of my colleagues has a good best line for this. Edge is not technology. Edge is a place. but there are actually multiple edges, and that's why it gets so confusing, because people come at it with a different perspective depending on what they're working on as to what is the edge. So from the perspective of an enterprise, the edge may well be their premise, that something happens at their location. And that's the area that is absolutely driving today. There's a lot of applications that enterprises want to deploy that have a latency sensitivity, and so putting stuff either in a private cloud or a public cloud ends up being unworkable. And you also have the opportunity when you have edge computing for low latency is to add connectivity to that, such as private wireless networks. So we're seeing a lot of use cases at the enterprise edge, warehouses, logistics, manufacturing, smart retail. There's many, many examples. And that's really happening already with private LTE moving to private 5G. I think the other main category, and some people will refer to it as ETSI MEC, sort of what was originally defined by the standards body, is at the carrier edge. So within T-Mobile's network, you have the opportunity to also provide a very low latency service, but across a wide area. So unlike an enterprise location, you can cover the entire city, the entire state, the entire country. And so people think about that as a space where augmented reality, vehicle to X, gaming, a number of applications that can be deployed there that really, can't be done today in a meaningful way, in a public cloud or other places. And to me, that's the most interesting one because that's a brand new area, brand new services for consumers, brand new services for enterprise, and brand new revenue opportunity for our industry. So I don't know if you wanted a monologue, but there we go.
I would add to that, we've seen some interest in the enterprise to actually put edge on, in vehicles on drones where you're processing
edge
data.
Edge the place.
Right.
Yeah.
Or you're processing your data on the edge, theoretically, and then moving that process data to cloud instances as well. So, edge could be as simple as a mobile phone. It could be a little bit more complex, like industrialized computing on, UPS truck as an example. But we always said that the edge is the Wild West. It has not been figured out. And once you figure out the computing, the app model hasn't really nested yet either, right? Because the edge, I don't think we'll ever get to a world where you see applications wholeheartedly deployed on edge infrastructure. It's always going to be a home base, whether it's cloud or private cloud computing. So then the edge and the orchestration of applications on the edge is still a very big nut to go solve. It hasn't been solved yet.
Yeah, it's actually a combination of a number of things too. So edge need not be a single location, if you will. It could be edge of the network, could be enterprise prem, or could be at the cell site, right? So it kind of depends on the use case. And effectively, edge is what you define it and kind of driven by what the enterprises and the customers want.
Okay, well, thanks, you guys. So maybe we may hold you a little bit more into edge, then coupled with the 5G network, and kind of from capabilities and performance, what we can expect.
Yeah. So if you look at MEC, multi-access edge compute, right? So you can have MEC over a Wi-Fi network, over a 4G network, and a 5G network, right? So effectively, 5G is the first time that you're actually bringing the power of like a super high-speed network, combining that with edge compute capabilities, and that kind of enables a whole host of use cases across many, many, many verticals, right? Smart cities, automotive, industrial automation, you name it, right? So this is like the first time where you can actually realize the true potential of 5G, like low latency. And if you look at T-Mobile's case, we have deployed 5G across multiple spectrum bands. So you have low band, mid band, and millimeter wave, right? So you could stitch all of these spectrum assets together, have a really fast network that gives you low latency, and combining that with MEC truly enables a whole host of applications.
Okay, great, thanks, Mehul. So maybe, Jim, you could elaborate on some of these applications, or what's the business prop, and especially from what you're seeing with a lot of the companies that you work with in 5G oil.
Yeah, we've had 71 teams through the program, 5 batches. Our 6th batch comes online in September. One of the teams that I always reference is Innovate Ag, and they use data to help transform the agriculture business. They've created a mechanism using a side-by-side that has LiDAR radar on it, as well as smart cameras and then soil sensing equipment. And every 5-acre block of scanning that they do in a tree fruit crop will generate north of 10 terabytes of data. Well, imagine trying to move 10 terabytes of data in rural America where you literally don't have any connectivity really. And so they've resorted to actually building a data center in their trailer to actually process that data. We're now starting to experiment with industrialized computing on the side-by-side. So as that data is being generated from those devices, we can actually process some of that data. And when they have the connectivity online, they can actually start to move that to their cloud instance. They happen to run their application in Microsoft Azure. That is quintessential one of the easiest use cases that you can point to. T-Mobile's done a lot of work with another one of our teams called Halo Car, right? Where now you've got a car that's teleoperated to where the driver is going to be. And from the time that the car gets summoned to when it arrives to the customer, it's fully teleoperated. You need to have onboard compute that's going to process all of that data to safely get that car to the customer. So that's another example. And then we're seeing other markets like healthcare, in coal production, where you're seeing coal mines. One of our other teams is actually supporting Kirkland Lakes Gold. It's called Expedo. Fully autonomous fully autonomous mining operations for gold production in Canada, all running off a private mech. And there you go, is another example of an immense amount of data that's being generated that the network needs to process so you can have this safe operation of these autonomous vehicles. And I can go on for days about other use cases, but those are the earliest. And what we're seeing, and I'd like to get your opinion on this, John, but we're seeing enterprises saying we actually need this capability of edge much, much closer. We're just scratching the surface on it.
I mean, 100%. We obviously see it the same way, that there's going to be a tremendous growth of demand. And I think it's the most exciting time in a way, because we could sit up here and dream of use cases all day, and we wouldn't even scratch the surface of what will happen, because it's a real crystal ball question. And you can go back to when 4G came, right? The 3G to 4G. Look, I got all this gray hair. Nobody would have dreamed of all the applications that came and the change that came. And at the time, it didn't feel like much. The initial play was, is this that much of a big thing? But when you look back, you realize a ton of new industries, a ton of new things were enabled. The same thing is going to happen with 5G, maybe even more so. And I know a lot of people here in the audience are looking forward to making examples or developing their own applications here. And so really, it's down to us as an industry to get the tools in the hands of the innovators, so that the innovators can go out and find things that we won't dream of.
Right. If you don't mind, keep me honest on this if you disagree, but private 5G for enterprise is really about edge.
I completely agree. Private 5G for enterprise is really about edge, because what you want to do is, the examples you gave are perfect. You need low latency communication, connectivity, for some kind of data that you want to process locally, because either there's a connectivity constraint or some other reason, maybe privacy. There's lots of reasons why you may want to do that. And so that the two go together perfectly seamlessly. And
that's actually a great example of the opportunity for the CSP world, for T-Mobile and other carriers around the world. When customers are knocking on your doors around private MEC or private 5G, it's more than just the connectivity. There's a ton of workloads and use cases on the other side of those networks that are driving business transformation, and frankly, a ton of really interesting spending. And that's why I think T-Mobile's network is poised for such great success in that world, just because that's a whole new defined space.
Yeah. A great point to make, sorry, just one quickly. A great point to make is people start to think of 5G as a Wi-Fi alternative. Well, you're not going to put in 5G to take your laptop to the conference room. It's got a different set of attributes, a different set of use cases. And so the two technologies will end up being complementary, but used for different reasons.
Sorry, Erin, I get pretty passionate about this area.
No, I love it. So maybe back to the comment about enterprises. What's, I guess, the biggest challenge or hurdle for them moving forward and implementing these solutions?
One of the biggest challenges that I've seen, and I'm going back to 20 years at Nortel and PeopleSoft and Oracle. When Oracle and PeopleSoft decided that they wanted to enter the SMB market, they took PeopleSoft Enterprise and shoved it into the SMB space and said, this is good. It actually wasn't, and it created a whole host of opportunity for the Intuits and others who came behind them. In the enterprise world, taking carrier-grade networking and trying to shove it into the enterprise is actually over-engineering what they really need. And so I think we're at the early sort of horizons of the enterprises and their real needs for private cellular networking, which today will be 4G LTE, 5G, and then eventually 6G and beyond that. And I think the industry is going to really adjust to that. That's why you're seeing Expedos like from our lab or a Solona or other players emerging in the space, because the needs for cellular connectivity in enterprise hasn't been fully vetted, but it's very different from running a national scale network. You don't need as much infrastructure. You don't need as much redundancy. And so that world is an interesting world, and I think it's an opportunity for folks like T-Mobile to say, okay, I can run this for 110 million subscribers, I think is that you have today, but I have a 30-acre campus, right? So I don't really need quite as complex a network.
Right. I think that the biggest challenge is that a lot of the enterprises are transitioning from Wi-Fi, right? And they want effectively they want the same ease of use over a private network as well, right? So they're moving from the Wi-Fi world to a 3GPP cellular world just for them on the enterprise. And so they're looking at how do I get connectivity, like who's going to give me SIM cards, how do I manage connectivity in the enterprise, how do I manage the radios, right? The core network that's going to be deployed, maybe optionally with MEC as well. And so they're looking at people like T-Mobile to kind of guide them through the whole process. And it's early days, it's still emerging. And so a lot of these enterprises that we are seeing and engaging with are kind of getting used to this new world. For them, it's a brand new world. And so I think it's kind of a learning curve initially at the beginning. And I think some of them are kind of getting used to the world of CBRS and licensed spectrum and site walks and site surveys and things like that. So definitely promise there. But again, as I said, it's very early days.
So you talked about them getting used to this new world. If we get to talk a little bit about the edge computing ecosystem and who are the players in that and what are the types of devices?
Well, you can look at it, obviously, edge computing infrastructure. Dell is a leader in that space. There are other players there as well. I think the point around 4G today and 5G in the future is largely due to the endpoints and the devices. Today, the endpoints and devices are still very available at 4G. They're down at lower cost, lower prices. The 5G devices are just coming. And that'll be the main gating factor, I think, in 5G being able to take forward. It has a lot of capability. We've got to get the rest of that part of the ecosystem there.
And then getting the device ecosystem ready, whether it's chipsets, modules, and then packaging them together into like let's say an industrial robot, for example, that runs around the factory floor, all controlled over a private network. So there's tons of players in this space, all kind of coming in. They started with CBRS, LTE, and now we are seeing that the interest has kind of shifted towards 5G now, right? But the chipset and the modules have kind of still being seeded in the market. And so all of the players in this space are making that rapid transition from private 4G to now they just call it private networks. It's private 5G now. Yeah, and then the MEC ecosystem is like a lot of the well-known players are in the ecosystem. All the public cloud players have private MEC offerings. They have public MEC offerings. Yeah, we see a lot of excitement in this space.
I guess, how do you see this coming together when you talk about those players? What are the challenges? I mean, you've got a lot of players. How do you get everybody at the table? How do you get that organized?
Well, when you're in a cloud environment, you sort of have a governed hardware stamp and software orchestration, so it's kind of easy to create these scaled services. When you get to the edge, it's very different. The standards, there isn't a standard for it today. There's some work being done in that area, but to an app developer, you could be running edge workloads on a mobile phone or an industrialized PC or something else. And so that world hasn't been sorted. I think it's safe to say containerized applications is going to rule supreme on the edge just because of the lightweightness of those applications. So Kubernetes and orchestrators around that world, I think, are really, really important. Microsoft's made some big moves with Azure Arc. AWS is doing something similar, as is Google with Anthos. So I think that world, when you bring the hardware ecosystem to bear with the software ecosystem, I think we're going to see some really interesting things in that world.
There will be a learning curve, I think, for the industry, to learn what are the capabilities of edge computing, what are the capabilities of 5G, private 5G, as well as slicing and low latency and some of the things that will happen in the network. So people who are close to it, of course, have been talking about this for a while, but again, I think the real innovation comes as the innovators finally get these tools in their hands and start to experiment and develop, and they'll think of things we never thought of.
So you talked about some of the challenges with standards. One of the questions that actually was submitted during registration was, and I hear often, is security. how do we need to treat security different when we look at 5G and edge computing?
Well, I think the most important thing is security and edge computing gives the enterprise a chance to really get in control of security. So everything is behind their own firewall. They can set their own policies. Even when you take things over a wide area network, there's more risks that are introduced. So I think that that's one of the most important things is being able to get control for the enterprise.
In addition to what John was saying, I think the surface attack area for edge is so broad and wide. We've seen great innovations. Mixed Mode is one of the teams that we've worked with that's using artificial intelligence to deploy probes on networks and start sniffing out nefarious actions, things that humans can't see, things that policies don't catch. So you're seeing a lot more AI being infused in security today beyond zero trust that fundamentally changes the way security is done.
I want to go back. You mentioned a couple examples of partners through 5G Oil and different types of verticals. What do you think is going to be the vertical, whether it's within the enterprise or outside of enterprise, that's really going to go to market first? It's really going to lead the way.
Manufacturing and transportation and energy are the three leading segments that we've seen a lot of investment in this world. COVID actually helped accelerate a lot of the investments in that. One of our partners, Accenture and Avanade, on the systems integration side, talks often about the resiliency that manufacturers didn't have pre-COVID, that they're now investing through IT spend to build resiliency into how they build products and ship products internationally, with less dependency on human intervention on that. So you're seeing a lot of lights-out manufacturing investments in play today, of which private networking is going to play a big role, as will edge computing as well. So those are the three big ones. I'm also seeing healthcare playing a pretty big role in this longer term. Retail, I think there's a lot of experimentation on the retail side too, but those three are the ones that I'm seeing. I'm curious to get your perspectives.
No, actually, I was going to add retail as well, and I think to some extent it could be rolling over, right, as the IT organization gets comfortable with edge and 5G in logistics in the warehouse. That same IT organization then starts to think about what they could do in the store, especially a large chain nationwide. And that's another place where, again, the carrier's got a great opportunity because, putting something in the carrier's edge to service 100 Starbucks versus trying to do something at each and every one of them, is something that's going to be interesting as well.
Right. And on the consumer side, I think mixed reality is very promising. We've already seen early versions of, those headsets that you wear and kind of, the early stages of metaverse, right? So I think mixed reality is going to be big in the coming years. And we are starting to see a lot of traction in mixed reality also in the enterprise space. So one of the use cases is, a construction crew, wearing these headsets, able to visualize, kind of like the bare bones of a building that's under construction. They can see, kind of gesture and kind of pull things apart and kind of, use that as a training kind of environment. So I think not metaverse, but the mixed reality space as a whole is going to be very, very exciting and up and coming in the next couple of years.
Is that what you're most excited about?
I am.
It is fascinating. You're right that it's both consumer, games and toys.
Correct.
But it's got a great enterprise application, right? Think of any field tech, any repair person in the field can take advantage of that. And so, that's another great innovation.
So we have a couple questions that came in during registration that I'm going to share with you guys. So the first one is, how fast is the industry moving from classical RAN model to edge computing?
Well, I guess I think of the two as interrelated, but not exactly the same. So, part of the vision would be that I'll try to interpret the question. The classical RAN model had a lot of dedicated hardware that was used just to be the RAN. And so, as other parts of the telco network have, moved to take advantage of virtualization, network function virtualization, that is now moving into the RAN. So with vRAN and Cloud RAN, Open RAN, there's different things. And the second step of that can be once you have, common computing hardware running the RAN, that creates an opportunity to co-locate, to co-host edge applications. So I think that I'm just trying to read into what the question is, but I think that That's going to take a couple steps, though, right? We've got to get the RAN from proprietary hardware to COTS, and then create the opportunity to do other things, which is, by the way, the same way the data center migrated in the enterprise. A lot of dedicated hardware to dedicated applications. All of a sudden, it became shared. There was a lot of extra latent compute and storage available by doing the sharing, and that created the innovation for the cloud.
Thank you. You mentioned costs, and that was something I wanted to bring up earlier when we talk about some of the challenges in terms of implementing these solutions and the different models. What are your thoughts in terms of managing those costs and making something feasible for enterprises of all sizes?
Yeah, I think it's safe to say we're early innings on private networking. We have an instance of GenXCom running in our lab, and it was done in less than 30 minutes and a few $1,000s. Freedom Phi is the same thing. You can set up a network with a $600 form factor PC from Intel, and you're off and running with a CBRS license, for less than $5,000. But those are really early use cases. It's not industrial grade yet. But to John's point, as the industry continues innovating and coalescing around new standards, I think Open RAN in the enterprise world is going to be a big factor, just for the open interface access. I do think the costs will drive down. You don't have to look too far. If you go back to the early days of cloud computing, I think it's safe to say that Amazon and Microsoft and Google all sort of played this same card, right? They would call their friendly OEMs like a Dell and buy a bunch of servers, and then eventually the costs were high enough where they said, well, we're just going to go straight to the folks who are actually integrating and building all these things, and so they called the ODMs and did that thing, and then now they're at a point where some of them are actually integrating themselves. So if that pattern continues in the 5G world, I think we're going to see similar evolutions of the ecosystem evolve. That's going to get not only the price performance down to something more broadly available, but the simplicity of the networks to be easy as well for the enterprise.
I completely agree, and I think the other one is you hit it earlier, the manageability, trying to make it much simpler, for an enterprise to deal with CBRS and SIM cards and all the complexity that our industry brings along. So that sort of day-to-day operations, we got to make sure we're able to drive down that cost.
All right, thank you. All right, so I'm going to pause on asking questions and turn it over here to our audience. If you guys have questions for our panelists, we've got the mics right here. Just walk up and ask a question. Yeah. Yep, go right ahead.
Erin, thanks for this wonderful session, first of all. My name is Prashant. I'm from T Technology Services. My question is to Mehul, to you. Like you're developing the technology around private networks, edge computing, but how critical is the role of partners in developing solutions around it and also, deploying? And second question is about, how you're finding in terms of the challenges to monetize the overall private networks.
Yeah, so I think partnerships are very important. I think as T-Mobile, I don't think we can do it alone, right? So obviously we partner with the enterprises, figure out what their use cases are. We bring in people into the mix, right? So we've got partnerships that we have already announced as part of our ANS solutions. So we work with them, work together, and also a key thing is on the application space. Once you put the basic plumbing, if you will, right, in the enterprise, the key is how to actually effectively use that infrastructure that's already deployed. And neither the enterprise can do it alone, neither T-Mobile can kind of do it alone, right? So we've got to work together with our partners and see what makes sense from an application point of view. In a lot of the cases, the enterprises have their homegrown applications, right? They basically work with application developers, third parties to source that, and then kind of bringing them all together, you need partnership there. Yeah. And then your second question was on monetization, right? So it's early days yet. So I think a lot of the enterprises are kind of wanting to try a whole bunch of things. So first of all, I mean, as I said earlier, since they're transitioning from Wi-Fi, there's a little bit of a learning curve for them. And so a lot of these enterprises are working with us, deploying trial systems, and trying to get a good feel of what the technology can do. How easy is it to manage, right? And then I think the monetization piece will follow, right? So I don't have a clear answer on how we're going to monetize, but there is a lot of levers that you could pull to be able to, monetize, whether it's connectivity, whether it's managed services, whether it's layering on some application on top of it, along with our MEC partners. So there's a bunch of a lot of things that you could actually effectively combine and monetize.
Thank you.
Oh, got a question? Yes.
Hi there. I'm Steve Rose from IBM. What would you consider to be, this is really a question to you actually, but also another question to you too, and I suppose in the second half, what would you consider to be the technology decision points that will enable us to actually have the trough of disillusionment sort of at the lowest, shortest possible, sort of profile? And that's really from an architectural, standpoint, and also from a commercial and go-to-market standpoint. Maybe you can share your view on that.
So specifically when it comes to private networks and MEC, I think we touched upon that a little bit. I think enterprises, in some cases, they don't have a lot of patience, right? Because there's real money involved there. So when they actually make a decision to move from one connectivity paradigm to another, if it doesn't work well for them, their sense of disillusionment is really, really high, right? We've had cases where enterprises may not understand the technology very well, but they really expect it to work, right? And so initially, the feedback is, hey, why doesn't it work that easy, right? I mean, isn't it that easy as, I turn on my laptop, I press the Wi-Fi button and it connects, right? So why can't I do that with my a thing, right? Is it a robot? Is it one of the other modules that they're using? So I think we as T-Mobile and as an industry, if we can help them overcome that initial kind of uncertainty and doubt, then I think that the disillusionment with this new technology will actually go down over time. And that takes time, really. But we've seen people actually kind of warm up to the idea of, hey, doing cellular connectivity within the enterprise, what that really, really means to their business. So total cost of ownership of one technology versus another, if that's really, really clear to them, then you see a lot of these enterprises adapt that new technology. And then as a result of that, the value of uncertainty kind of goes down and the disillusionment kind of becomes low. So.
Stephen, I think you know that we, the lab, plus our partners, partnered with another organization called Maritime Blue, and we did a feasibility study here at the Port of Tacoma around what could having private wireless access do for the port, and we interviewed a bunch of operators there, like Husky Terminals, Tote, and others. I think the pain, to add to the point made, the pain has become so great because what they've had to resort to is laying out fiber drops with Wi-Fi access points to do some basic connectivity stuff. And where logistics is going, there's going to be a lot more automation and robotics involved. They have to get there. And we've all seen the supply chain challenges here in the United States and all around the world. A lot of that could be done with humans, and they're amazing at it. But the complexity of these networks has gotten to a point such that they have to rely on computing and automation and others. And that's just one example of other industries. So to just add to the point, I think in certain industries, the pain has become so fundamental that they're now just moving forward with it. And that's why that's why I've seen enterprises are bidding actively for CBRS spectrum. John Deere famously has done that. In Germany, I think it was BMW, Mercedes, ThyssenKrupp, and others are actually now bidding on public spectrum because the pain has become so unbearable, I guess, that they're having to experiment.
Well, I think it's both getting the connectivity, but also then the speed after you get it. Right?
Absolutely.
So you have much greater reliability of communications with 5G than with some other options. And so you just think about the robot that drives around the warehouse. We've all seen that on TV on different shows. Well, the way those work is if they lose connectivity, they stop. And that's fine. It's nice and safe. But if you didn't have that problem, then you'd be operating that much faster. Port's a great example of a wide area scenario. So it's going to be a learning curve, and there's going to be false starts, people who, as you say, they sort of expect it to work and maybe don't really know why they're doing it in the first place. I actually, my very first job was in the oil business. We had people driving around, there was hundreds of acres in oil fields just looking for leaks, and you can do all of that stuff with automation and save a ton of money and also, be a lot more reliable. So that's where it's going to play.
I do have a question. So in terms of going through this transition, what would you say is kind of the biggest misunderstanding or misconception that these customers have moving into cellular network solutions?
the biggest issue.
Yeah, I mean, what do you think is there just like, just misunderstanding of taking that leap or starting that transition?
What I have seen is some CXOs that I've spoken to, they believe that there's a proliferation of 5G devices that are in the market today, and so they build these networks that are 5G standalone, anticipating that there's a plethora of devices, and there just isn't. So that's an easy one. That's low-hanging fruit. The second is around the application models, right? So if I'm deploying an application now on the edge, how do I manage it? How do I secure it? How do I actually have devices speak to it? That's another world that most CXOs are looking at deeply and trying to figure out their world view on that. And the other one, and you might see this as well, John, is how do you generate the ROI models to validate that this was the right investment
For new things, for sure. I think the other one maybe to mention quickly is spectrum, because the CIO is not typically thinking about what spectrum license do I need in order to run my application. And unfortunately, if you're an application or a developer or innovator and you want to take your product globally, the spectrum rules are national. Every country's got a different play. A lot of the innovation in Germany is because they've made it quite easy for enterprises to get their hands on spectrum. I think unfortunately, the regime in the US with CBRS is one of the more complicated. But different countries are doing different things. And hopefully once, that's the kind of thing that they can copy each other as well. Right? Once the innovation starts to happen in certain places, the regulators will see that, and hopefully we'll see that go around. But that's, in terms of a misconception, that's one that's, kind of a, What are you talking about?
Just to add to that, I think some folks think that CBRS is that lightning rod, and when they start deploying these networks and realizing, oh shoot, I can only get 120 megs, top end performance down.
Yeah, and I got to renew my license every 10 minutes.
Yeah. Yeah. We actually saw that we have 2 operating field labs in agriculture here in Snohomish County, and that was one of the big aha moments for us. Was like, hold on, we can only do this much bandwidth. That's how are we going to move 10 terabytes worth of data off the farm to an edge processor, right?
Yeah, and I think the biggest misconception is, hey, it's a private network. I can get ultra low latency, and I can pull down gigs and gigs of data, right, over like a 1 Gbps link, right? And the answer is no, right? If you deploy CBRS, you're not going to be able to pull down and get those kind of throughputs and speeds. So it's kind of, as I said, it's a learning experience for them. But the biggest misconception is like, hey, if I do 5G CBRS in N48, for example, right? Will I be able to get 200 megs down and 100 megs up? Like, maybe not, right? So.
Any other questions? Oh, Grant's got one.
So I guess this is for Jim and John. I get to talk to him all the time. But I guess my question about edge compute is, back in the day, many years ago, all companies built servers on-prem. Yep. And then the cloud providers came along, and slowly companies are like, hey, I'm not supposed to have compute on-prem. I'm supposed to have it off-prem, right? So now they're all sending it up to the different clouds. So the only people that have on-prem left are those that haven't gotten the message or those that really have to have it there. Like there's a real business reason you're supposed to be on. Right? And some of that's maybe latency, which I get, like I think with 5G and that helps, right? Some of them are, I think, security or control reasons. And I don't know how much of that's real. Like, they think they must have control, but honestly, if they got the memo on how to do cloud right, it's very secure and it would be okay, right? I'm trying to understand, how much edge compute is there really out there? If you really talk to these businesses and you really understand the technology and stuff, how much should really be on-prem? Because when I look at it, I'm like, actually, most of these things could be in the cloud. It can be secure. Latency's pretty good. How much do you really think is there that needs to be?
So what you're referring to is branch computing back in the day. And the best thing about technology, we do these pendulums and just rebrand them as different things. So that's actually not going away. There's also this tribal myth early on, and I had been at Microsoft when Azure was just getting its foothold. We all thought the enterprise would, who would run its own his or her own data center. The reality is hybrid is clearly going to be a long-term play in the enterprise. You're never going to see, not never, it's unlikely that a full enterprise is going to go full cloud, right? There's always going to be some on-prem for some reason. Amazon's fulfillment centers actually has edge computing running at those locations. And we're talking about Amazon, right, which is a fairly influential cloud provider. So there's certain use cases where even if you have the best network, a 5G network from T-Mobile, the best latency performance, better than anybody in the world, you're always going to have a situation like an Amazon fulfillment center or other enterprise use cases where you truly need minimum 5 milliseconds or below, right? Because you've got packages that are going down a conveyor belt at 20 miles an hour, and you need to make very quick decisions. So you can't do that when you're trying to run something over a network that's 10 miles away, 20 miles away. You start to butt up against physics at that point. But then you have countries like Germany where you have to have that data sovereign. And so CIOs, I think, are constantly challenging, trying to challenge that world. John, you probably see
I feel like you answered your own question away, right? Because you hit the top two, latency and security. And I think your example is exactly right. If you need to gather data and act on data, and you gain a business benefit from gathering the data and acting on it quickly, then you can't afford the round-trip delay. You need to use the data locally, process the data locally, take the action. I'm reading from a sensor, I'm telling a robot to do something. And that absolutely, will have a business benefit. I think that the security side, you're right. I think there are other ways to solve it. And that I'm not really, an expert in that domain. But, whether it's the GDPR rules in Europe or other things like that, force that stuff to stay where it is. Now, this is received wisdom from me, so I can't claim that I know it to be 100% correct, but I was told that there are only 600 data centers, if you add up Google, Amazon, Microsoft, the main hyperscalers, IBM probably. So if you just think about that, right, that's going to be a fair distance from an awful lot of places. There's a lot of remote places. You gave the mine example. So I think Jim's answer is exactly right? The application is going to find what's appropriate. Public cloud's great for a lot of things. Private cloud's great for a lot of things. Prem is great for a lot of things.
Thank you.
Hello. Okay. Hagai Pen, AWS. This is actually a question from Mehul. With the multitude of application, edge, networks, private networks, what are the key challenges T-Mobile are looking at to solve orchestration of all those activities throughout those networks and application, and how are you handling them?
Yeah, so that's a great question, right? Not too long ago, we were looking at use cases, or a use case in particular where in the automotive world, cars go all over the place, right? So anchoring a data session in one location, but still being able to serve the real-time compute needs of whatever the car is doing, right? Real-time maps, HD, and all of that, right? So that at the application layer, that's got to move along with the vehicles. So you just can't anchor it in one place and expect that you're driving from Seattle to Atlanta, for example, right? As you go further and further away, that latency becomes more and more. And so one key problem there was how do you basically serve the needs of an application that has real-time compute needs in mobility scenarios. So you've got to do a number of things at the network layer. You've got to think about session mobility, continuity, maybe relocating the gateways, right? And standards do address a lot of these things, but it's very, very early right now. And then even if you do that, at the application layer, again, taking AWS as example, right? East and West is not going to solve the problem for you. You have to have applications deployed across all of your local zones, right? And then to be able to orchestrate the application across these deployed instances in a mobility scenario, I think it's key. So that's just one example. But I think it's a very good example because the automotive world, very, very, very sensitive to these kind of problems. And so I think that is one key thing that the industry has got to solve. Yeah.
How is T-Mobile addressing it right now?
I'm sorry?
How is T-Mobile addressing it right now?
Well, so we are actually working, so we obviously have a lot of the folks in the standards, right, that represent T-Mobile. So we're actually very aware of what's going on in the standards. We're taking that and we're actually instantiating them in our labs, trying to test it out. But there's only so much you can do. So I think we are looking at partners to kind of validate these scenarios. And only then we'll be able to, so that we have actually solved maybe a subset of the problem or maybe the entire problem. So it's a work in progress. I don't think we have a solution right now. Neither does the industry. But we do have the levers, standards, application space, and then along with partners like the hyperscalers, I think we can get to a point where we will be able to solve it.
Thank you. Question?
So I hear a lot of talk about sort of 5G, sort of the the gateway to MEC. So because you hear a lot about latency and so on and so forth, all these wonderful traits about 5G. Do you see or have you come across any use cases where you're using 5G in automation to manage user data using 5G policies? For instance, do you ever come across any sort of use cases of that manner?
I don't know, Jim.
Go ahead.
No, Jim, do you have any from the oil?
Maybe the answer is no.
Yeah, go for it.
No, I'm just trying to think. I certainly heard that as an idea, but can't say I've seen it. So
5G is not a destination. 5G is an enabler. Just like cloud computing is not a destination, cloud computing is an enabler. We haven't talked about LoRaWAN. We haven't talked about what's going on in the satellite world. There's a ton of stuff that's being done in that world as well. I think 5G is critical to the enterprise in a very big way. I do think it changes some of the IT policies just because of the pervasiveness of where these devices are going to be on networks, not one network, but multiple networks. I think the security thing that Erin asked earlier is a whole new world. We've had enterprises talk to us about a myriad of, in one conversation, like, how do I do LoRaWAN-based networking so I can pick up IoT data on critical use cases and parlay that to my 5G strategy? Wi-Fi is not going away, so Wi-Fi needs to be sort of involved in all this. Here's what's important. To the enterprise, the network pipe has just gone boom. And it's going to open up a whole new set of use cases. On the software development side, the teams that we work with in the lab are looking at this whole new world of the edge and realizing, wow, if I have critical connectivity and I've got computing, the application ecosystem is going to go boom. And we're starting to see some of those early days as well. The bigger challenge that we're having is on the security side is on the data side. I mentioned the 10 terabytes worth of data for Innovate Ag. That's just a pittance of what's really out there. In 2010, the world generated something like 2-point-something petabytes worth of data. In 5 years, it's going to be 161 petabytes of data. That's crazy. And digital transformation is all about data. It really is. And all of the stuff that we're talking about serves the cause of where data goes and how enterprises make sense of that data real time. And what I see really exciting for T-Mobile in this world is that network not only provides best-in-class connectivity, but the network could actually play a pretty functional role, not just connecting, but potentially even computing and making sense of this data on the far edge. That's where T-Mobile's value to the enterprise just skyrockets over time. Does that help answer your question?
I think it does. I mean, basically, looking at everything you mentioned is, without that data, it becomes a need to categorize it, filter it, and be able to manage it,
Right.
and with policies and such. So what 5G brings is sort of a standardized framework where you have so many different, it's such a fragmented field.
Very much.
5G could be unify that area of the business,
Right.
and so that you could manage this enormous amount of data according to very strict, government policies. So
Sure.
that's where the policy and controls come into play.
And maybe the canary in the coal mine in that, my friend, is IoT. I think IoT is having a second wave, if you will, maybe even a more plausible second wave, where some of those harder discussions are being had right now.
Thank you.
Yeah. Erin, I have a question for you, if I don't mind going off script.
No, go for it.
So, Erin maybe you touched on this. Erin covers the 5G, Erin and your team cover 5G Hub, 5G and Me, and the Tech Experience Center.
Yes.
And you've seen a multitude of enterprises that are coming through and seeing all these experiences since before COVID, when we met 3.5 years ago, I think it was,
Yep.
to today. How have the conversations changed from your standpoint, relative to the enterprise conversations that T-Mobile's having?
Yeah, I mean, I think over obviously the last couple of years, well, we've been talking about 5G for
A long time.
a long time. And what's great now is 5G exists, right?
Yeah.
And we have a network, and thanks for your great answer earlier, we have an amazing network and a very high-performing network. And I think now they're seeing that these potential applications are actually a reality. And so now we're getting more of less trying to explain what 5G is and what those possible applications are, but more of how do we do it?
Yeah.
You know, what's next? What do I need to do to make this happen? So that's what's really exciting, and I think that's what's now really great about having the 5G hub is we can now take that next step with them and bring them in here. And I think Mehul, you mentioned earlier about actually working with these partners as we continue to optimize our network and figure out how is this deployment really going to look and how is this all really going to come together. So I see now we can start having those conversations and those partnerships, which is really exciting.
One thing I really appreciate is we went from here's what's possible when we first met to here's what we can do today.
Yes.
Which is, it's a light year distance from where we were to where we are today.
Yeah,
which is really fun. And then the makerspace here at the 5G Hub is just a great place to innovate, get your hands dirty, and really tackle those tough challenges.
Absolutely. Thank you.
Yeah,
We're very excited. Yeah. All right. I think we have time for another question or two. Do we have any other questions from the audience? Yes.
Hi, my name is Gaurang. So question more for Mehul or you or Grant. So T-Mobile's, again, whatever publicly available, we try to understand from that. How T-Mobile is looking towards PAN? Is it going to be mostly the extension of the existing network per se, or is it going to be a real private network, as Jim mentioned, with low-cost device, low-cost radios, low-cost on-prem core integrated to T-Mobile network?
I think it's all of the above. So if you look at the ANS portfolio that we have announced of services, right? So I think there's 3 tiers in there. The first is just the public network that we have today, right? You can get connectivity over the public network. We have great connectivity to the cloud providers today, right? So you can obviously have that tier working for you. The second tier is what we call the hybrid tier. Is basically it's still shared spectrum. If you walk into a building, for example, in building, if you don't have good in-building coverage, we can work with you to deploy radios in building, right? And the traffic is still carried over the public network. Or what you could do is you could branch off from an in-building radio and have a local UPF if you want to, right? And that's coming. That's not current capability, but it's something that we're working on. And then again, your workloads. If the workload is in the public cloud, we connect to those clouds, right? You can have that. If you want to deploy an instance of Mac on-prem with a local UPF in the future, right? That's certainly an option. And then you can run your workloads there. Now, if these two do not work for you, for an enterprise, for whatever reason, then the third option is basically a completely private network where you have your own private radios, your own private core, which is on-prem, right, with an optional Mac solution as well.
And using T-Mobile Spectrum, I guess?
Yeah, so again, if it's the public network, it's whatever spectrum we have deployed. The last one, I mean, we are keeping our options open, right? We have certain spectrum assets that we could leverage for a completely private network. Now, what those could be kind of depends on the use case, but it's certainly an option.
Thank you.
All right, one last. Yes, Mike.
I guess what I'm curious about is, does ARM architecture have a place in 5G edge computing? Like I would assume T-Mobile, as it stands now, the majority of UEs on the network are probably ARM-based. And with the proliferation of these edge appliances, is there a space for ARM on 5G edge?
Huge.
Yeah, absolutely.
Yeah. ARM, GPUs, absolutely. Well, you're seeing this a lot too, right?
Yeah. I think it's like anywhere else in computing, right? The most appropriate technology gets adopted. So there's nothing to keep ARM out, and it has a lot to say for itself, just like it does in any other applications.
Yeah, you're seeing a lot more ARM processing in data centers today, obviously on IoT devices. Yeah, there's a big ecosystem for ARM and GPUs and classic x86 architecture as well.
And we're seeing that technology, potentially move into the RAN itself as well.
What's really interesting is, well, Apple's made its move with M1. The Google phone that I've got's got Tensor chip in it. So you're seeing a lot of homegrown architecture, RISC architecture, or ASIC rather, architecture that's actually being developed. And I'm curious to see where that technology goes as well, in addition to where ARM's going. Yep, of course. It's a really fun time to be in this space right now.
I know.
Really fun time, yeah. And there's a huge software ecosystem that's just on the other edge of that opportunity that we're all collaborating on building, which is really fun. Yeah.
Okay, so I have one final question. So what is the one takeaway for our audience or call to action? I mean, we've got great representation here in this room. What would you tell everybody here? What can we go do to really help push this forward?
My huge takeaway, if I can go first, is it's going to be a very dominated world by software. Absolutely dominated by software, both applications. We talked about ORAN. We talked about a lot of different things. I think software is going to play a very big role, not just in the use case development of it, but kind of where this technology eventually nets out over time. So don't keep your eyes too far off the software game. I think it's going to play a very big role in that.
I would say open your mind, because we all get caught in a rut. We do things the way we do them. We assume that's the best. We assume that's normal. Or, well, by definition, it is normal. But there will be, just like there was with other technology innovations we've seen, there will be new possibilities opened up that you maybe won't immediately think of. So the call to action is to think through your business processes, think through the opportunities, try to make an effort to understand what can become available, and think about how that, there's new things that you could do that no one's thought of to improve your business.
Okay, thanks, John. Mehul?
I think the key takeaway is stay tuned, right? We as a company are putting together this tremendous 5G network that's going to be used in ways that we have not even imagined yet. And we are just, as everybody said, we are just scratching the surface. It's early days, it's emerging, but it does have the potential to truly unleash something really, really great. And I think, as you said, once software developers can know what the access network is capable of, I think we'll see some really, truly amazing things come to life.
All right, so I'm going to answer this question too. And I'm going to say the call to action is to innovate with us. So that is what we do here at the 5G Hub. So especially when we talk about new technologies, 5G and edge computing. If you have a POC, a project, initiative that you want to bring here, we have, as you guys can see, this incredible facility. We have the technology, we have the experts here to bring these solutions to life and start innovating. So go to our website, submit your project there, and hopefully you'll be here soon innovating with us. And also, we are going to keep these great conversations going. Our next speaker series is August 16th, and we will be talking about 5G in smart cities. Talk a lot about 5G capabilities and how they're going to enable new solutions for our cities and local communities. So we have your emails. Watch for the invite and register, and we hope to see you guys on the 16th. All right, so with that, let's give a big thank you for our panelists. Thank you so much, you guys. Appreciate your participation and your insight. Also, thanks to our audience. Thanks for joining us this evening. Some excellent questions as well. Good news is the bar is still open for at least another 30 minutes, and we still have some food over there. I think there's even brownies and Rice Krispie treats. So please hang around, do some more networking, and enjoy your evening. Thank you.